The Hubble Ultra-Deep Field is an image of a small region of space in the constellation Fornax, composited from Hubble Space Telescope data accumulated over a period from September 24, 2003, through to January 16, 2004. Looking back approximately 13 billion years, it will be used to search for galaxies that existed at that time. The HUDF image was taken in a section of the sky with a low density of bright stars in the near field, allowing much better viewing of dimmer, more distant objects. The image contains an estimated 10,000 galaxies. In August and September 2009, the Hubble's deep field was expanded using the infrared channel of the recently attached Wide-Field Camera 3. When combined with existing HUDF data, astronomers were able to identify a new list of potentially very distant galaxies. Located southwest of Orion in the southern hemisphere constellation Fornax, the rectangular image is 2.4 arc-minutes to an edge, or 3.4 arc-minutes diagonally. This is approximately 1/10 of the angular diameter of a full moon viewed from Earth. Smaller than a 1 mm by 1 mm square of paper held at 1 meter away, and equal to roughly 1/13 millionth of the total area of the sky. The image is oriented so that the upper left corner points toward north on the celestial sphere. On September 25, 2012, NASA released a further refined version of the ultra-deep field dubbed the Extreme Deep Field. The XDF reveals galaxies that span back 13.2 billion years in time, revealing a galaxy theorized to be formed only 450 million years after the Big Bang event. On June 3, 2014, NASA released the Hubble Ultra-Deep Field image composed of, for the first time, the full range of ultraviolet to near-infrared light. Planning. In the years since the original Hubble Deep Field, the Hubble Deep Field South and the Goods sample were analyzed, providing increased statistics at the high redshifts probed by the HDF. When the Advanced Camera for Surveys detector was installed on the HST, it was realized that an ultra-deep field could observe galaxy formation out to even higher redshifts than had currently been observed, as well as providing more information about galaxy formation at intermediate redshifts. A workshop on how to best carry out surveys with the AX was held at STSCI in late 2002. At the workshop, Massimo Stiavelli advocated an ultra-deep field as a way to study the objects responsible for the reionization of the universe. Following the workshop, the STSCI director Stephen Beckwith decided to devote 400 orbits of director's discretionary time to the UDF and appointed Stiavelli as the lead of the home team implementing the observations. Unlike the deep fields, the HUDF does not lie in Hubble's continuous viewing zone. The earlier observations, using the Wide Field and Planetary Camera 2 camera, were able to take advantage of the increased observing time on these zones by using wavelengths with higher noise to observe at times when Earth's Sheena contaminated the observations. However, AX does not observe at these wavelengths, so the advantage was reduced. As with the earlier fields, this one was required to contain very little emission from our galaxy, with little zodiacal dust. The field was also required to be in a range of declinations such that it could be observed both by southern hemisphere instruments, such as the Atacama Large Millimeter Array, and northern hemisphere ones, such as those located on Hawaii. It was ultimately decided to observe a section of the Chandra Deep Field South, due to existing deep X-ray observations from Chandra X-ray Observatory, and two interesting objects already observed in the Goods sample at the same location: a redshift 5.8 galaxy and a supernova. The coordinates of the field are right ascension 3 hours 32 minutes 39.0 seconds, declination minus 27 degrees 47 minutes 29.1 seconds. The field is 200 arc-seconds to a side, with a total area of 11 square arc-minutes, and lies in the constellation of Fornax. Observations. 4 filters were used on the axe, centered on 435, 606, 775 and 850 nanometers, with exposure times set to give equal sensitivity in all filters. These wavelength ranges match those used by the goods sample, allowing direct comparison between the two. As with the deep fields, the HUDF used director's discretionary time. In order to get the best resolution possible, the observations were dithered by pointing the telescope at slightly different positions for each exposure, a process trialed with the Hubble Deep Field, so that the final image has a higher resolution than the pixels on their own would normally allow. The observations were done in 2 sessions, from September 23 to October 28, 2003, and December 4, 2003, to January 15, 2004. The total exposure time is just under 1 million seconds, from 400 orbits, with a typical exposure time of 1200 seconds. In total, 800 axe exposures were taken over the course of 11.3 days, 2 every orbit, and NICMOS observed for 4.5 days. All the individual axe exposures were processed and combined by Anton Kokummer into a single set of scientifically useful images, each with a total exposure time ranging from 134,900 seconds to 347,100 seconds. To observe the whole sky to the same sensitivity, the HST would need to observe continuously for 1 million years. The sensitivity of the axe limits its capability of detecting galaxies at high redshift to about 6. The deep NICMOS fields obtained in parallel to the axe images could in principle be used to detect galaxies at redshift 7 or higher, but they were lacking visible band images of similar depth. These are necessary to identify high redshift objects, as they should not be seen in the visible bands. In order to obtain deep visible exposures on top of the NICMOS parallel fields, a follow-up program, HUDF-05, was approved and granted 204 orbits to observe the 2 parallel fields. The orientation of the HST was chosen so that further NICMOS parallel images would fall on top of the main UDF field. After the installation of WFC3 onto Hubble in 2009, the HUDF-09 program devoted 192 orbits to observations of 3 fields, including HUDF, using the newly available F105W, F125W and F160W infrared filters. Contents: the HUDF used to be the deepest image of the universe ever taken and has been used to search for galaxies that existed between 400 and 800 million years after the Big Bang. Several galaxies in the HUDF are candidates, based on photometric redshifts, to be amongst the most distant astronomical objects. The red dwarf UDF 2457 at distance of 59,000 light-years is the furthest star resolved by the HUDF. The star near the center of the field is USNOA 2.00600-01400-432 with apparent magnitude of 18.95. The field imaged by the axe contains over 10,000 objects, the majority of which are galaxies, many at redshifts greater than 3, and some that probably have redshifts between 6 and 7. The NICMOS measurements may have discovered galaxies at redshifts up to 12. Scientific results: high rates of star formation during the very early stages of galaxy formation, under 1 billion years after the Big Bang. Improved characterization of the distribution of galaxies, their numbers, sizes and luminosities at different epochs, allowing investigation into the evolution of galaxies. Confirmation that galaxies at high redshifts are smaller and less symmetrical than ones at lower redshifts, showing the rapid evolution of galaxies in the first couple of billion years after the Big Bang. Successo. The Hubble Extreme Deep Field is an image of a small part of space in the center of the Hubble Ultra-Deep Field within the constellation Fornax, showing the deepest optical view in space. Released on September 25, 2012, it took 10 years to compile the images and shows galaxies from 13.2 billion years ago. The exposure time was 2 million seconds, or approximately 23 days. The faintest galaxies are 1/10 billionth the brightness of what the human eye can see. The red galaxies are the remnants of galaxies after major collisions during their elderly years. Many of the smaller galaxies are very young galaxies that eventually became the major galaxies, like the Milky Way and other galaxies in our galactic neighborhood. The HUDF contains about 5,500 galaxies even within its smaller field of view relative to the 2003 and 2004 view.